Okay, let's have a look at practice 2. It's on page 288. It's chapter extended book 14.1. We're going to look at B, F, and G here, and then 2A. Okay, so this is B. This function here, x to the minus 1 minus 4 is 1 over x minus 4. Now we're looking at where it is greater than or equal to 0. Well, it's at that root there, that point, well anyway, where it crosses the x-axis, right there, is where it is greater, is between greater than 0 and less than 0.25 or less than a quarter. So the solution there is x is greater than 0 and less than or equal to 0.25 or a quarter. Again, what this is saying is that in this region here, between 0 and a quarter, that blue line is above the x-axis. It's greater than 0, because remember, the function was, where is that function greater than or equal to 0? Well, it's equal to 0 at 0.25, and then everything less than 0.25, but not including 0 there, okay, in the first quadrant. Okay, so that was the solution for B. All right, that was B. Let's now have a look at F. Okay, we're looking at F. Now having a look at F. Now this is a little bit trickier just to visualize here. Just keep in mind that the asymptote for the left-hand side is minus 5. That's when the denominator equals 0. And on the right, it's going to be minus 3 on 2. Okay, just keep that in mind because we need to know that to find the solution. Okay, so I drew the asymptotes there. This green line here is the asymptote for this blue function. Okay, that's where it is heading to infinity. This is the same here. And the yellow is for the red function there. And we said that was going to be at minus 3 on 2. And this value here, the green, that line there is on minus 5. Minus 5. Okay, indicated here, that minus 1, 1 is that point there. That's where the blue and the red intersect. So one of the regions in here where the blue is less than the red, right? The blue function is less than the red function, is from that point there, the intersection point, to the asymptote. So that's from minus 1, and we said that asymptote is at minus 1 on 5. So that would be one region there between that intersection and that asymptote. Now the other region where the blue is going to be less than the red will be everything after this asymptote. And we said that asymptote was at minus 5. So the other possibility is where x is less than minus 5. Sure, it is a little bit hard to recognize from here, but what you should do is put these functions into your calculator, zoom in a little bit and have a look at the areas we're talking about. Okay, so we've got x is less than that asymptote, is where the blue line is less than the red. And in the region of less than minus 1, which is that intersection point and that yellow line. Let's have a look at G now. Okay, here's the output from my calculator. The blue function, that's our 1 on x, and the red function is 1 on x plus 3. So we're looking for where 1 on x is less than 1 on x plus 3. Okay? All right, I've drawn in the asymptotes. This green line is the asymptote for this function, the red one, and the yellow one is sitting on the y-axis, and it's the asymptote for 1 on x. All right, so that green line there is at minus 3. Okay? So it looks like the blue function is only less than the red function from less than 0 and greater than minus 3. Okay, so that's x greater than minus 3 and less than 0. Okay, so that is this area where blue is less than the red. Okay, in that area there. Let's now have a look at 2A. Okay, in this question here it says when two resistors R1 and R2 are connected as shown, the total resistance R is multiplied by the equation 1 on R equals 1 on R1 plus 1 on R2. That's resistance 1, resistance 2, and the total resistance. We're going to do A. R2 equals 2 ohms. So when R2 equals 2 and R must be at least 1 ohm, find R1. Okay. Let's write this down. So we have the expression 1, or the equation 1 on R equals 1 on R1 plus 1 on R2. Okay. So we know that R2 is given as 2. So we'll substitute that in. So we've got 1 on R equals 1 on R1 plus 1 on 2. We're going to flip all of this, but before we do, let's sort out the right-hand side. So I've got that equals, we're going to make the common denominator as 2R1. If that's the case, that's 2 at the top there, plus R1 here. Okay, so now we've got 1 on R equals that. So we can flip that, and we can then rearrange that. Therefore, R equals 2R1 over 2 plus R1. Now they also told us here that it must be at least, R must be at least 1 ohm. So let's include that information. So R is greater than or equal to 1. Okay. So all we need now to do is to equate that R, or just to substitute that in for that. So we're saying R's got to be greater than or equal to 1. If this equals R, then we can say that 2R1 on 2 plus R1 must be greater than or equal to 1. And let's use the second method that we learned in the examples. So we're going to say that this must be greater, 2R1 over 2 plus R1 minus 1. That must be greater than 0. Okay, and we can see from here, that's from the calculator, and I found the point where it crosses the x-axis is at 2. So this function here is greater than or equal to 0 for any value of R greater than 2.